Consider this system of linear equations. There are three equations in three variables, and in equation 3 there are two unknowns, lambda and nu. It is given that this system of linear equation has infinitely many solutions. Then we have to find the radius of circle centered at this point lambda nu, and touching this line 4x equals to 3y. So basically from here we have to find the value of lambda and nu using the condition that this system of linear equation has infinite number of solutions. And once we have lambda and nu, the center of circle will be known, and then because it is touching this line, the line is tangent to the circle, radius of the circle, that will be nothing but perpendicular distance from the center of circle on this line. So basically the problem is to find the value of lambda and nu, and then we can find the radius of circle by calculating the perpendicular distance of this line from the point lambda nu. Also, in some of the problems, you will find that instead of writing infinitely many solutions, they will write that this system of linear equation has more than one solution, right? So in that case also, it will mean the same thing. A system of linear equation can have only three possibility. Either it will have unique solution or no solution or infinite number of solution. So if it has more than one solution, then also it will have infinite number of solution. Now, we know that for infinitely many solutions, the condition is that delta is 0, that is determinant of coefficient matrix is 0, and delta 1, delta 2, and delta 3. These three, they are also 0, right? So by using these conditions, we have to find values of lambda and nu, and then we'll calculate the radius of this circle by calculating the distance of that tangent line from the center of circle. So now let us try to find lambda first. For infinitely many solution, the determinant of coefficient matrix, this must be 0. That means in first column, we'll have uh, 2, 7, and then 12. Right, that should be the first column of coefficient matrix. Coefficient matrix means these numbers 2, 3, 5, 7, 3, minus 2, and then we have 12, 3, and minus 4 plus lambda. So first column 2, 7, 12. Then second column is 3, 3, 3. And finally the third column, this will be 5, then minus 2, and then minus lambda, minus 4. Right, so this is the determinant of coefficient matrix. And because the system of linear equation has infinitely many solutions, this determinant must be 0. Now, it is not difficult to solve this determinant. If you want, you can create two zeros also, because we have identical element in second column. So if you want to create two zeros, you can do this row operation, that in place of R1, you can write R1 minus R2, and in place of R2, you can write R2 minus R3. Using this row operation, we can get two zeros uh, in one row or one column, and then we can expand along that row which have maximum number of zeros. So if I do 2 minus 7, that will be minus 5, 3 minus 3, that will be 0, 5 minus 2, this will be 7. Similarly, 7 minus 12, so again minus 5, 3 minus 3 is 0, and then lambda plus 2. And here we have 12, then we have 3 minus lambda minus 4, and this determinant must be 0. So if I expand this determinant along the second column, because we have two zeros here, then we'll get minus 3 into, and then we have minus 5 into lambda plus 2, and then plus 7 into 5, so that is 35, this equals to 0. So from here clearly you can see that the value of lambda plus 2, this will become 7, that means lambda must be 5. So this must be the value of lambda, right? By equating the determinant of coefficient matrix to 0, we got lambda as 5, right? We need lambda and nu, so we have calculated lambda, this is 5. Now let us try to calculate nu, and for calculating nu, uh, we can equate either delta 1 to 0 or delta 2 or delta 3, anyone we can equate to 0. So maybe we can equate delta 3 to 0, right? Because in that way we'll get rid of this third column. So if I equate delta 3 to 0, first row, this will be 2, 7, 12. Then we have 3, 3, and 3. and the third column will be 8, 9, right? C3 that will be replaced by these constant on right hand side. So 9, 8 and then 16 minus new. This will be delta 3. So 9, 8 and then 16 minus new, and this must be 0. So again, you can do the same sequence of a step. You can create two zeros and then you can calculate new from here. After calculation, you will find that value of new, this is 9, right? So that means the point lambda new, that will be 5, 9. We need the radius of circle which is just touching this line. That means this line is the tangent line. So the radius of circle, that will be 4 into, when the line is 4x minus 3y equals to 0. So 4 into lambda minus 3 into nu, magnitude of this thing, and that divided by in denominator root over a square plus b square, right? That is standard formula for finding distance of a point from a line. So in denominator we have 4 square plus minus 3 square, and obviously in numerator we need to take modulus of this thing. So clearly you can see that this will be 20 minus 27, so that is 7, and 4 square root of this thing, right? Root over a square plus b square. So after calculating this, you will get 7, and 4 square plus 3 square root will be 5. So that should be the radius of circle, 7 by 5. Right? This was not a difficult problem. I mean, using the condition for infinitely many solution, the condition is delta 0, and then delta 1, delta 2 and delta 3, those three are also 0. So delta 1, delta 0, from there we got lambda as 5, and then delta 3, 0. So from there we calculated the value of nu, right? Lambda was 5 and nu will be 9. So therefore the center of the circle will be at 0.59, and then we need the radius of circle. So that is nothing but distance of this line 4x minus 3y equals to 0 from the point 59. That distance is 7 by 5. So therefore the correct answer for this problem is first option.